Hi, this is Mr. Manley. This is a video for students that are familiar with the law of sines, and this video is about using the law of sines to solve triangles where there's potential for something called the ambiguous case. And what we have when we're solving triangles is we are trying to find the measures of all of the angles and all of the sides. So if I've got a triangle here, A, B, C, and then A, B, C is how we label it. In order to solve a triangle, we need to be given three pieces of information, a combination of sides and angles. The possibilities are that we could be given the three sides, we could be given two sides and an angle like this, we could be given an angle, side angle, and we could be given an angle, and a side. If we're given three angles as our three pieces of information, that is a triangle that we cannot solve because it is not a unique triangle, meaning that there's more than one triangle. There are infinite number of triangles that have the same three angle measures. All these everything else would provide a unique triangle. There's only one triangle that could match the values that are given with the three pieces of information. Looking at these choices, all we need to focus on here is SSA, because this is the only case that can potentially be ambiguous. And what does that mean? Well, we're going to take a look right now. Looking at the information that's given here, I'm given the three pieces of information, two sides and an angle. We should begin by drawing the triangle, and we want to draw it to a pretty nice approximate scale, because that'll act as an internal check. Here I am placing angle A, which is 29 degrees, and then opposite of angle A, I'm going to have this side A, and let's look and see where I'm going to put B. If I put B down in this corner here, then that means that side B over opposite angle B has a measure of 10. Now when I put A here, here's angle A. When I put that in, I want that to be a length of 6. If I look at that in relation to B, I needed to be shorter than B, about half of B. And it just so happens that this will work out pretty well if I just draw it into where I put that point down there at the bottom right-hand corner. That would make sense, that looks like about A is equal to 6 compared to B is equal to 10. We want to draw it to a good approximate scale, relative, each side relative to the other sides and each angle relative. Now we're going to go into the law of sines and we're going to solve. What do I have? I have an A of side 6, an angle of 29 degrees. I have a side of 10, and then I want to solve for sine B. Solving for sine B, and this is just some basic algebra that you should be able to do. I'm going to have sine 29 degrees over 6 times 10 when I solve for sine B. And then I say B is equal to, and let's do the calculation, evaluate what B is equal to 0.808, and that's what sine B is equal to. All of this is 0.808, but I want angle B, so I'm going to do the inverse sine of both sides, and we've got that B is equal to the inverse sine of 0.808. Let's evaluate that in the calculator and see what we get. we get 53 degrees. 53 degrees. And when I look at the triangle over here, that makes sense. That angle B looks like it could be 53 degrees. And I can put that in there. And then we can solve the rest of this triangle, right? I'm not going to do all of that, but we could solve and we could find this angle here, angle C, by using the rule of 180, right? If we have two of the angles of the triangle, we can find the third by the rule of 180. And then with the law of sines, I would be able to find this side C. But there's something interesting here, which is that I could have another way of doing this A equals 6. Look at the triangle here, and if I drop down this red line here, if I drop down the red line like this, I'm still going to have an A of 6. Therefore, there's a completely different triangle that will meet the stipulations that were given of A is 29, A is 6, and B is 10. Let's pull that triangle out. And if I've got a triangle that looks like this, where I've got angle A is 29 degrees, side A is 6, and side B is 10. Now, remember back here where, down in the bottom left, where I got B is equal to 53 degrees, the other possibility, the ambiguous case, because ambiguous means we're not sure, it's one or the other. The ambiguous case, this other angle is going to be, the angle in this other possible triangle here is going to be 180 degrees minus this first angle that we found, 180 minus 53 degrees. And that will give us a angle of 127 degrees for angle B in the second possible triangle. Okay? Now this is only coming up when we are doing an SSA triangle, but it doesn't always come up with every SSA triangle. Let's look at another case. Here's a case where I've been given a side, and an angle. Let's draw the triangle. I've got 26 degrees for angle A. And then if angle or side B is 5, and then I'm going to actually make that a little bit smaller, and then I need side A to be about four times as long as that side B. So let's draw a side out here that's about 4 times longer than that side B, something out here maybe, right? And then I need to extend this side, this other side to match it. And that'll give us out here in the bottom right is angle B, up here is C. Okay, we're going to go through the same process. Let's write in A is equal to 21. We're going to use our law of sines. I'm going to be looking for angle B. I know side B, and I have angle A. I'll do the sine of that over side A. And let's see what we get for B. B is equal to the inverse sine of 0.104. And I didn't write, we know up here in the, if you look back in the equation, that A is 21 and B is 5. And then we could solve for B, get this inverse sine is 0.104. And then that means that B is equal to about 6 degrees. Okay? And if I look here, I see that that makes sense. That B is some small acute angle, right? And we're getting that that is 6 degrees. And then I could go and solve for C. Now, what happened in the previous case? Let's look back. Back in the previous case, I drew a second triangle, right? Right down here in the right, then I said, all right, I solved B, but there's a second triangle. And I did that. Now look at what happens when we try to do that here. Even if without drawing it, and then also look at how did we actually find it, we took the angle that we knew and we subtracted it from 180, right? So if we try to do that here, and I'm trying to do some other triangle, and let's call this B1 for the first triangle. Now say I'm going to do B2, and B2 is supposed to be 180 degrees minus 6 degrees, which would be equal to 174 degrees. So now look at that, 174 degrees for some other angle B in the ambiguous case. So presumably there's some other triangle that we can draw, right? And that's going to have this 174 degrees. But already, if we look at the new B2 and then we look at the other given angle, which is A, that's more than 180 degrees. Okay, so this is an SSA case. This is an SSA case that is not ambiguous. SSA is possibly ambiguous, but not guaranteed to be ambiguous. And you can tell, one way that you can tell is that if A is greater than B, or if the side that is given opposite the angle is larger than the other given side, so if the side that is opposite the given angle is larger than the other given side, it cannot be ambiguous. And you can look at that over here, look at the triangle that's given, and you can see if I take this, see this is my side A here. There's no way I can bring that around to make a different triangle. It doesn't fit. So there is only one case. Just one other note, and this video is running a little bit longer than I like videos to run, so I'm not going to do this last part, but I am going to comment that this is a third case of SSA, and I'll show you the picture. The third case of SSA is here. I've got an angle B that is 78 degrees, and I've got a side C, I'll put here, which is 12, and then I've got an angle, or a side B is over here, right? So this is where side B would be, up here, and this side B here is 5. Now look at this, look at that, compare it to the 12 over here. A side of 5 is not going to reach down. It's not going to make it. So this is actually an SSA. This is actually an SSA with no solution. We could have a no solution SSA as well. Okay, so there's some discussion of the ambiguous case, and we see that it only is with SSA, and it could be ambiguous, or it might not be ambiguous, or it might be no solution.